let's discuss very interesting topic of this chapter, that is degree of polynomial. Now what is the degree of polynomial, that you must be thinking, right? This is very interesting topic and we are going to do classification based on this as well. Remember, while we were discussing classification based on terms, I told you that we are classifying polynomial based on two categories. First was number of terms, another is this one, that is degree of polynomial. First of all, let's understand the term and do few examples based on it. Let's start. Now, degree of polynomial is the highest power of the variable in polynomial. Okay, very simple to understand. You need to take the maximum highest power in the polynomial, right? So suppose if we take example of this polynomial, that is 2x plus 1. Now what we are interested in, power of the variable, and that should be highest. So first of all, let's see how many times variable is there. Only one time, right? And what is the power over here? That is 1. If nothing is there, what do we keep as the power? 1, right? So in this case, degree of polynomial is what? 1. Very simple to do. Let's discuss next question. Here, x cube minus 9x plus 3x raised to 5. No need to rush to decide the degree of polynomial. 3 is here, here power is 1, and here power is 5. So what we want to write? Highest power of the variable in polynomial. So 3, 1 and 5. So which is the highest? Very simple, we know very well, right? So answer is degree of polynomial is 5 in this case. Now, interesting question about 4. Now what is the degree of polynomial in this case? This is very interesting, right? So how can we identify? Is it 1, 2, 3, 4, 5, something like that? Okay, now see, we can consider this 4 as x raised to 0. Why I am writing x raised to 0 over here? Now we know that whenever 0 is in the power, the answer is always what? 1, right? So this property we know very well, x raised to 0 is equal to 1. So either I write this x raised to 0 or not, it doesn't make any sense. It is not changing the polynomial, right? The polynomial remain same. So if you see, now you see that 4x raised to 0, what will be the degree of polynomial? What is the highest power in this polynomial? That is 0. So in this case, DOP is what? 0. Very simple to do, right? Remember this explanation, 4 into x raised to 0. If you have any fraction as well, minus 5 by 2, minus 10, any number can be there. You just write into x raised to 0, you will be getting the answer as degree of polynomial 0. Let's discuss next question. Here, y raised to 4 into 1 minus y raised to 3. Remember, whenever you have something like this, rather than directly judging the degree of polynomial is 4, simplify first. Always simplify first, right? So let's start with simplification. First, I will be multiplying y raised to 4 with 1. So that is y raised to 4 minus y raised to 4 into y raised to 3. That is y raised to 4 plus 3. That is 7. Now see, there are two powers over here, 4 and 7. But degree of polynomial is what? Highest power of the variable in polynomial. So highest power is what? 7. So DOP is 7. Very easy to do. Remember, don't write 4 as the answer because that's incorrect. DOP is what in this case? 7. Simplify first, then decide. The last one, x plus 1 into x minus 1. Again here, we need to simplify like the previous one. So this is identity, a plus b into a minus b is equal to a square minus b square. Square of x, that is x square minus square of 1, that is 1. Now DOP, very simple it is, right? Highest power of variable in polynomial. Now highest, there is only one variable here, like the first case. So only 2. So this is how we find the degree of polynomial when we have polynomial in one variable. Remember, highest power of the variable will give you the degree of polynomial. If it is given simply, then you can check the maximum highest power, that will be your answer. If there is no variable, you can put x raised to 0, so DOP will be 0. If you need to simplify, then simplify first, then you decide, right, like we did. So this is how we find the degree of polynomial. Now let's learn how to find the degree of polynomial when we have more than one variable, right? Previously we discussed only with the one variable, that was x only. Now here if you see in the question that we have x, y, right, in most of the cases. So let's start. So it's all about the power, we know very well, right? Here x raised to 3, here 2 and 2, okay? Here 1 and 1, here 1, and there is no variable at all. So in this case, power is 3. In this case, x square and y square. So what shall we take? Only 2? This is very interesting case. See, 2 and 2, that will combine and make 4. Always remember, whenever there are more than one variable, you are supposed to add the power. It doesn't matter it is x or y, just add the power. So 4 here. Here 1 for the x, 1 for the y. So if we add, we are going to get 2. Here x raised to 1 and here 0 will be there. So 3, 4, 2 and 1. So which is bigger? Obviously 4. So degree of polynomial will be 4. Simple, right? You are supposed to add the power when you have more than one variable. Let's discuss second case here. So in this case, power is x raised to 2 and x raised to 1. So 2 plus 1 will be 3. And in this case it is 5. So what will be the degree of polynomial? That will be 5. Simple. Degree of polynomial as 5, right? Add the powers when you have more than one variables. Otherwise, no, you're not supposed to add it. That's simple. And the last one, here 1 as the power, 1 plus 2, that will make 3. And here 1 and here power will be 0. So what's the answer? That is 3. Remember, the only thing which is important and different than the previous cases, when you have two variables, you are supposed to add the power, and whatever you get it, that power you should consider for that particular term, right? For this term it is 4, for this term it is 2. Here it is already 3 because it is one variable. So this is how we find the degree of polynomial for the one variable and two variable. Now let's learn how to classify polynomials based on DOP. So far we discussed the one classification of polynomials based on the number of terms, monomial, binomial and trinomial. Now let's discuss another classification which is based on degree of polynomial. So let's start with that. So degree of polynomial, if it is 0, it is called constant polynomial. We discussed something like this, right? There was a question, 4 was only given and we have written 4 into x raised to 0, right? So in that case, power of x is 0. So what is the degree of polynomial? 0 it is, right? So we can just write for an example, 4 could be minus 2, it could be 1 by 2, it could be as well. Then next is linear polynomial. Now linear polynomial, you must have learned linear equation in grade 8. Yes, it's similar to that. In that case, you have only power of variable as only one. That is linear polynomial. So if we want to write an example, we can write as 2x plus 3. It is in the form ax plus b, where a cannot be 0. If a is 0, then it will become what? Constant polynomial. So this is the condition over here, right? Next is quadratic polynomial. Now quadratic polynomial means what? Degree of polynomial 2, right? And so if we write an example, this could be something like this, that 2x square plus 5x plus 3, right? 2x square plus 5x plus 3. Now see over here, degree of polynomial is 2, right? Highest power is 2. Here it is 1 and here there is nothing. So quadratic polynomial. If degree of polynomial is 2, we call it quadratic polynomial. Next is cubic polynomial. Power is 3. Let's take an example. So x cube plus x square plus x plus 1. See, highest power is 3, 3, 2, 1 and finally 0. So 3. So this is the cubic polynomial. We are going to discuss in next session that how we are dealing with quadratic and cubic polynomials. Next is biquadratic polynomial. Biquadratic means what? Right? Quadratic means 2. Biquadratic means 2 times 2, that is 4. So the degree of polynomial will be 4. So we just need to add one more term in this case, that is x raised to 4 plus x raised to 3 x square plus x plus 1. That is an example of the biquadratic polynomial. And finally, zero polynomial, whose degree of polynomial is not defined. Generally, an example we can write as 0 only. It's the best example of that, right? So this is how we classify the polynomials based on degree of polynomial. Remember, 0 constant, 1 linear, 2 quadratic, 3 cubic, 4 biquadratic, and for 0 it is not defined. Now let's discuss few questions based on this. Let's solve the problems based on classification of polynomials based on DOP. Classify the following as linear, quadratic and cubic polynomials. Let's start. So first step is to find the degree of polynomial. Now degree of polynomial in this case 2 and 1 is 2. So what will it be? Quadratic polynomial. Simple. Now second case. So what's the degree of polynomial here? So DOP, that's here 1, here 3. So highest power is the DOP. So that's 3. Here it is cubic. It is cubic polynomial. Next one, here let's talk about the power. Here 1, here 2 and here there is none. So we will take degree of polynomial as 2. Again it is quadratic, right? And the here 1 plus x, we know very well, I think this way easy to guess, right? Degree of polynomial is 1, so it is linear. It is linear. If degree of polynomial is 1, then linear, 2, then quadratic, 3, then cubic. Very simple to solve. Now let's solve for the next one. Previously we were having 2 terms, 3 terms at some point. Here only 1 term. Remember, we are classifying based on degree of polynomial. So DOP here is 3. So it is cubic. Simple, right? 3 means cubic. Next one, 3t. So what's the power of t? That is 1. So it is DOP is 1. So it is what? Linear, right? Linear polynomial. And the last one, r square, right? Again, power is 2. So DOP is what? 2. In that case, what will it be? Quadratic polynomial. So this is how we identify the polynomial based on degree of polynomial. If it is 1, we know very well, linear. If it is 2, quadratic. 3, cubic, right? And if it is 4, then it will be biquadratic. Let's move to the next topic.